Hello everyone. We shall be presenting our paper Exploiting Unlabelled Photos for Stronger Fine-Grained Sketch-Based Image Retrieval accepted at CVPR 2023. In this paper, we propose a stronger baseline for fine-grained sketch-based image retrieval that addresses two critical issues facing the community, namely inadequate latent-space separation of sketch photo instances and scarcity of paired sketches. For the former, we propose a simple modification to the standard cross-modal triplet loss by employing an intramodal triplet loss in each modality that explicitly enforces separation amongst the sketch photo instances. For the latter, we put forward a novel knowledge distillation module wherein we first pre-train a teacher on a large set of unlabeled photos over the aforementioned intramodal photo triplet loss and then distill the contextual similarity present amongst the instances in the teacher's embedding space to that of the student's embedding space. Our work overshoots prior state of the arts by almost 11% and also generalizes well on new classes. Over the years, Sketch has long established itself as a query modality that is complementary to text for image retrieval. Initially proposed as a category level task, recent focus has shifted to a fine grained setup that fully utilizes the faithful nature of sketches to conduct instance level retrieval. Despite great progress, all existing fine-grained SBIR models use the cross-modal triplet objective to learn the joint sketch photo embedding space, which however fails to retain the holistic latent space geometry, being overtly restrictive on learning within triplet feature separation. Furthermore, fine-grained SBIR also suffers due to insufficient sketch photo pairs. Through our work, we seek to address these core issues facing the community and propose suitable solutions to tackle each of them. Our first contribution is employing an intramodal triplet objective in both modalities in addition to the regular cross-modal triplet loss. This modification explicitly enforces separation among the sketch photo instances, resulting in a more optimal embedding space for instance level retrieval. Regarding sketch scarcity, we first train a model on unlabeled photos only using intramodal triplet loss and then distill its instance-wise discriminative knowledge to a retrieval model. The pre-trained model forms the teacher while the retrieval model is the student, and distillation is aided by introducing a learnable distillation token in our encoder architecture, which we shall be discussing shortly. Before going into the architectural details, let us look into a pilot study we conducted as a means to understand deeper nuances of fine-grained SBIR. We considered the conventional Siamese triplet network as baseline and studied three aspects: training stability, dataset size, and unseen classes. Fine-grained SBIR has been shown notoriously prone to training instability, which our model visibly improves due to the use of exponential moving average that imparts a stabilizing effect. Secondly, baseline FGSBIR was found to perform poorly under low label data setting, which our model mitigates thanks to the use of unlabeled photos during training. Thirdly, while baseline performance significantly drops for classes with no sketch photo pairs, our method maintains a stable performance via its knowledge distillation paradigm. Coming to the architecture, our encoder comprises a pyramid vision transformer which ensures a global receptive field compared to the local fields of CNN. We employ the standard cross-modal triplet loss along with the proposed intramodal triplet losses in each modality. For an anchor sketch, another sketch matching the paired photo is a positive, while any random sketch forms the negative sample. For an anchor photo, we consider its structural augmentation as the positive pair, while a different photo is considered as a negative sample. As it follows from the pilot study, we use EMA to increase the training stability. This training paradigm forms our stronger baseline, which we improvise further by leveraging unlabeled photos. To leverage unlabeled photos during training, we use a knowledge distillation paradigm. Specifically, we consider a teacher model trained on photo corpus using intramodal triplet objective, consequently learning instance level discrimination, and then distill its knowledge to a student retrieval model, making it more discriminative. To do so, we introduce a learnable distillation token in the PVT encoder, such that from the final layer, the student model outputs this discriminative feature as well as a distillation feature. The teacher is used to obtain pairwise distances of discriminative features from k nearest neighbors, while the student is used to obtain the distances between features of the input photo and those nearest neighbors found by the teacher. This is to preserve the structure of the teacher embedding space while distillation to the student. The two sets of distances are then softmax normalized to yield the respective probability distributions, which are used to compute the KL divergence loss. We follow a similar fashion to compute KL losses over the labeled data, that is both photos and sketches, and thereby train our full method in an end-to-end manner. For detailed clarification, please refer to the paper. We evaluate our model on benchmark fine-grained SBIR datasets, namely QMUL CHAIR-V2 and QMUL SHOW-V2, along with the category level Sketchy database. For leveraging unlabeled photos, we used photos from the Sketchy as well as UT-Zappos dataset, which comprises 50,000 unlabeled fine-grained images. Our competitors include the prior state-of-the-art works in fine-grained SBIR, along with their augmented versions using our intramodal triplet objective. We also compare against alternative architectural variants in both CNNs and vision transformers, which we adopt in our pipeline. Last but not the least, we also compare with possible alternative baselines that use additional unlabeled data, such as edge maps for sketches or alternatives to knowledge distillation. Coming to the results. It is observed that the proposed model, even without unlabeled data, can overshoot all prior state-of-the-arts by large margins. Compared to complex models like the meta-learned Style Me Up or reinforcement learning based on the fly, our rather simple modification addressing inherent problems in cross-modal retrieval provide much superior results. And we also see that a knowledge distillation paradigm for exploiting unlabeled photos yield a further boost of almost 4% over the PVT-based stronger baseline. We also perform a thorough ablation study on the loss objective in a stripped down fashion, where the importance of each individual loss term and the knowledge distillation paradigm are highlighted. Dropping the intramodal triplet loss lowers performance, while the stabilizing effect of EMA improves the results. The KL divergence losses also contribute significantly to the performance boost. Furthermore, in cross-category experiments with no paired sketches for unseen class, our model surpasses adopted baseline, while achieving results competitive to prior state-of-the-art. Thus, to sum up, in this work we present a PVT encoder-based stronger baseline for fine-grained sketch-based image retrieval that addresses the fundamental problems of latent space geometry and insufficient paired sketches via its learning paradigm. Our method is found to overshoot prior arts by significant margins, which justify its proposal. For more details, please visit our project website by scanning the QR code shown. Thanks for watching.